Hello everyone and welcome to our presentation. Today we'll be discussing white box testing. My name is Amy Williams and I will be presenting the first part of our presentation. I will provide an overview of white box testing and explain the process of how it is done. White box testing got its name from its transparency. It is a form of testing in which the tester is given full knowledge of the internal workings of the application. Testers are given access to all code, documentation, and databases if any exist. Because of this, white box testing is also known as clear box testing, structural testing, logic testing, or code-based testing. Whereas black box testing is only concerned with the input and its corresponding output, white box testing scrutinizes each element of the system, often unit by unit. It is important to note the differences between the types of testing in order to understand what purposes white box testing fulfills. White box testing gives the tester full access to the internal workings rather than external expectations or the limited knowledge of only high-level data flow and database diagrams of gray box testing. Because of this knowledge available to white box testers, one of its key focuses is strengthening security. White box testing also has the advantage of being able to improve performance. It is also aimed at improving design and usability. This diagram demonstrates some of the key aspects of white box testing and how it is performed. White box testing often has both static and dynamic testing elements. Static testing involves testing only the source code. This is done through code walkthroughs and code inspection. In this type of testing, code is not executed. Rather, it is determined if the code meets functional requirements, has been written according to its design, has all required functionality, and handles errors properly. Dynamic testing involves running the program against pre-designed test cases. There are multiple components of dynamic testing, including unit testing, unit coverage, and code complexity. We will not go into too much detail about these topics because they are outside the scope of our presentation, but we will go over some of the subcategories of unit coverage in order to explain what white box testing entails. Statement coverage is often included and requires that every possible statement in the code be tested at least once during the testing process. Path or branch coverage checks every possible path that could be taken in an application for validity. These include conditional statements and conditional loops. Condition coverage checks that each conditional statement or loop is tested and valid. Function coverage checks each subroutine of the program, ensuring that each is being called appropriately. There are a few categories that are not included in this diagram. One of these is failure test cases. Failure test cases allow for the tester to think of every possible input that a user could supply. Here, testers safeguard against accidental or intentional harm that could be caused. Inputs are tested for correctness, appropriate length, possible buffer overflow attacks, division by zero, and other problems and hazards. This testing is often done multiple times throughout the course of white box testing. It is done throughout the course of the project many times, including during unit integration and regression testing, and is a great way to test not only for correctness, but for performance, security, and many other factors.